All right, this is a video on ratios and proportions for our geometry class, and I'll start with a brief reminder and introduction, and then we'll do a few solved examples. So as way of reminder and introduction, I want to talk about first why cross multiplying works. You're often told by your teacher to cross multiply, and perhaps you're not ever really taught why it works. I hope you do understand that we can multiply both sides of an equation by the same value and the equation stays balanced. So that's what we're going to look at right here. And that'll turn into an explanation of why cross multiplying works. So let's look at this proportion we're trying to solve. 6 over x equals 5 over 4, and we're curious what x is. So let's multiply both sides by x first. And we're going to do that because we want to get x up and out of the denominator. Okay, so these x's will cancel. And we end up with 6 equals 5x over 4. Okay, now next let's multiply both sides by 4. And these 4's will cancel. And we'll get 24 equals 5x. Okay, and then lastly, we can divide both sides by 5. And these 5's will cancel. And let's bring it up here. We have 24 fifths, which is 4.8, equals x. So that would be our solution for x in this problem. Let's try this a different way using the cross multiplying method, and we'll look at some similarities. Okay, so once again, we had 6 over x equals 5 over 4. And so as a reminder, cross multiplying directs you to just diagonally multiply. Okay, and that would give us 6 times 4 is 24, and 5 times x is 5x. And once again, we have x is equal to 4.8. So let's think about what we just did. Here we multiplied both sides by x. Here we multiply both sides by 4. And over here, we simply did both of those steps at once. Okay, so cross multiplying is really just multiplying both sides of the equation by both denominators at the same time. So it's a totally legitimate mathematical operation, and it's a little more efficient than taking 2 steps to do it. So let's apply this cross multiplying rule to a few different proportions that we'll be solving. Okay, this first one we'll do x plus 4 over 9 equals x over 3. And I always like to look for some patterns here. We can see that the left denominator is 3 times the right denominator, and that would mean that the left numerator needs to be 3 times the right numerator. So there's one trick there that you might be able to figure out, but it's not quite super easy to figure out just from that trick. Let's do a cross multiplying here. So we'll cross multiply diagonally, just like we explained earlier. The important thing to keep in mind is we need to multiply 3 times the entirety of the x plus 4 inside parentheses, and then we'll do a distributive process. So 3x plus 12 equals 9x. All right. Subtract 3x from both sides, we get 12 equals 6x, and then we can divide both sides by 6, and so we get x is equal to 2, which would be our final answer. Think about that pattern we saw earlier. If we plug in a 2 here, we would get 6. If we plug in a 2 there, we obviously get 2, and 6 is 3 times 2. Okay, so that pattern we saw earlier where the denominator is 3 times the other denominator, that works as well in the numerator. So that's a quick way to check our work. Another problem you might come across is to write equivalent proportions. So the instructions here say if x over 6 is equal to y over 7, determine what the ratio of x to y is, or determine what x divided by y would be. We're not going to be able to solve for x or y as a particular value because we have 2 variables and only one equation here, but we can determine the ratio of x divided by y. So what I'm going to do first is cross multiply here. And basically what we want to try to do is is rearrange the equation to look like x divided by y. And we're going to start off by cross multiplying. So we have 7x equals 6y. Looking at our goal of x over y, we want y in the denominator, so let's divide both sides by y. And these y's cancel. And so we'll get 7x over y equals 6. And then we can divide both sides by 7. So we'll divide this by 7 and divide this by 7 as well. So these 7's will cancel. And I think you can see that we have x over y is equal to 6 over 7. So that would be our solution right there. And as a last couple problems, we'll up the challenge a little bit to solve a couple challenging proportions. This first one, we have 4 over x equals x over 9. Hope you can see why this might be challenging is we have a couple x's, and if you think ahead about cross multiplying, we're going to get an x squared. Okay, so we have x squared equals 4 times 9, which is 36. Let's square root both sides to solve for x. And so I have x is equal to 6. And then the common mistake is to forget about another possible number that would square to give you 36, and that would be negative 6. So our total solution there is x is equal to positive or negative 6. So don't forget about those negative numbers as well when we take square roots. Excuse me, if this last problem we'll get even a little bit more complex. And we're going to cross multiply there. And we get x minus 3 times x plus 2 equals 6 when we cross multiply in the other diagonal. Let's FOIL that out. We'll get x squared plus 2x minus 3x minus 6 is equal to 6. Looks like we have a quadratic equation we're going to solve. I'm going to try to solve it by factoring first. If not, we might need to use the quad formula. But to do that first, we need to get our equation equal to 0. X squared minus x, combining like terms, minus 12 equals 0. And it looks like this guy is factorable. X minus 4x plus 3. And that would mean x is equal to 4 or negative 3. And that's a good place to stop.